Hello, in this video I'm going to be doing an example of the ideal gas law. Alright, so let's start with question 2. It says, what volume will 2 moles of nitrogen occupy at 720 torr and 20 degrees Celsius? So we are looking for volume. Normally, if you were at STP, standard temperature and pressure, you could just use the 1 mole for every 22.4 liters. However, that only works at STP. Here we're at 20 Celsius, 720 torr. That's not standard conditions, so in that case you're going to have to use the ideal gas law, which is PV equals nRT. Kind of looks like pervert, or pivnert, as people like to call it. PV equals nRT. P stands for pressure, V stands for volume, N is the number of moles, R is the universal gas constant, and T is temperature. So, depending upon which number you use for the universal gas constant will determine whether you're going to be in ATM or kPa or liters or milliliters. For this class, I always suggest we pick 0.0821 liters times atmosphere divided by moles times Kelvin. That's going to be our ideal gas constant, which means our pressure is going to have to be in atmospheres, and our volume is always going to have to be in liters. Alright, with that being said, I've got 720 torr. So my P1, or just my pressure, is 720 torr. Man, looks like I'm going to have to do those pressure conversions way back from the gas law unit. So just to recap, 1 ATM is equivalent to 101.3 kPa, which is equivalent to 760 mmHg, which is also the same thing as saying 760 torr. So they're all equivalent to one another, meaning you can put them into a conversion factor, one on top, the other on the bottom. So I'm going to take 720 torr. I want to convert this guy to ATM, so I put 1 ATM on top. I'm going to put 760 torr on the bottom. 760 torr. In order to solve this, you're going to need a calculator. Good thing I have mine. You should have yours too. Alright, 720 divided by 760 equals 0.947 ATM. And in my Celsius, whenever I do gas laws, I got to be in Kelvin. So I'm going to take my 20 degrees Celsius and add 273 to convert it to Kelvin, and that's going to equal 293 Kelvin. I've got 2 moles, that looks good. Looks like I can start plugging it into my equation. Alright, so my P is 0.947 ATM. My volume is actually what I'm looking for, so that's V. My N is, it says 2 moles, 2 moles. My R is always 0.0821, that's a number you're going to have to memorize for the test. And my T, my temperature, is 293 Kelvin. From here, we just got to use our Math Algebra 1 skills. And there's multiple ways to solve it out. What I'm going to do is type in 2 moles times 0.0821, and then I'm going to times that by 293, and I'm going to divide both sides by 0.947. 0.947. That gives me 50.8 for my volume. 50.8, and since my ideal gas constant has liter unit, my volume is going to be in liters. Alright, one last thing, sig figs. It's the very last thing. So we go back to original problem. Looks like we've got 2 sig figs. That dash line for this worksheet, whenever you have a line over a number, it's saying that count that as significant. Otherwise it would just be 1 sig fig. But this is saying 2 sig figs. We got 2 sig figs, 2 sig figs. Looks like I'm going to have to round this guy, instead of 50.8, to 51 liters. And that is how you use the ideal gas law to find volume.